In this question, we have a ramp that is 10 meters tall and at an angle of 30 degrees. We are told that a ball is released from the top, and we want to know what is its velocity when it reaches the bottom of the ramp. Now, this is a motion on an inclined plane question, which means the acceleration is equal to plus or minus g sine theta. And we can use what we know to find the acceleration. We know g is equal to 9.8 meters per second squared, and our angle is 30 degrees. When we do the math, we find that the acceleration is 4.9 meters per second squared. Now, how did I know the acceleration is positive? Well, the velocity vector is pointed to the right, and we know objects going down an inclined plane are speeding up. So the acceleration vector has to be in the same direction as the velocity vector. That means it's to the right, so the acceleration is positive. We also know the ball's initial velocity, which would be 0 meters per second, because the ball is released from the top. Now the only other piece of information we need is the ball's displacement, so delta x. Now we can use trigonometry to figure this out. We have a right angle triangle. The opposite side is 10 meters and the angle is 30 degrees. We want to find the hypotenuse. That represents delta x. So we will use sine theta is equal to opposite over hypotenuse. We can rearrange and isolate for the hypotenuse, plug in our values, and we find that the hypotenuse of this right angle triangle is 20 meters long, which means delta x, the ball's displacement, is 20 meters. Now we have everything we need to answer this question. We will use the Vf squared is equal to Vi squared plus 2a delta x kinematic equation. All we need to do is plug in our values and solve for Vf, the ball's final velocity. And we find that Vf is equal to 14 meters per second. Now we can move on to part B of this question, which says that after the ramp, the ball continues to roll on flat ground. And we are told it slows down at a rate of 1 meter per second squared. And we want to know how far does the ball travel until it comes to a stop. Well, we know the initial velocity is 14 meters per second because that's the velocity the ball exits the ramp at. And we were told that the ball slows down at a rate of 1 meter per second squared. That means the acceleration is equal to negative 1 meters per second squared. I know this because the velocity vector is to the right, and if the object is slowing down, the acceleration vector has to be in the opposite direction. So it would be to the left, and it would be negative. And we also know the ball's final velocity. It would be 0 meters per second because the ball comes to a stop. And with that, we have all the information we need to solve this problem. We will use the Vf squared is equal to Vi squared plus 2a delta x kinematic equation, but this time we will rearrange for delta x, plug in our values, and what we find is that delta x is 98 meters. So the ball traveled about 98 meters before coming to a stop. And that's the end of this motion on an inclined plane question.